Hey guys, Mr. Herc here, and today I'm back with AP Precalc Lesson 1.2. Let's get right into it. All right, so let's start off with the bell ringer for today. Pause the video now if you haven't done the bell ringer yet, because I am about to go over the answer. And so here we want to see which of the following statements is true about the function g, which is to our left. And so the first part of all four answer choices I see is talking about the function and whether it's increasing or decreasing, meaning is it going up or going down. And so this function is clearly going down as we go to the right, and so this is going to be a decreasing function. So we can automatically eliminate A and B from our answer choices. Now the next part is a little trickier. This is talking about concavity. And so when it's talking about concavity, we want to see, is this function concave up or is this function concave down? Now remember, when it's concave up, the rate of change of any concave up function will always be increasing. And likewise, when a function is concave down, the rate of change will always be decreasing. So this function is clearly concave up, right? It forms an upwards U shape. And so the rate of change is going to be increasing. And another way of saying that, or like a fancier way of saying that, is that function is changing at an increasing rate, right? The rate of change is increasing. So C should be our answer here. All right, so just as a quick refresher, as we said last class, we introduced a new term, and that was rate of change. Now, basically, all you need to know for the definition of this is that it is the exact same thing as the word slope, right? So if one works better, if you feel more comfortable using the word slope, whenever you see rate of change this lesson and in the future for this class, just change it out with the word slope in your head. There's zero issues with that because those two terms are synonymous. All right, so here's kind of the learning timeline for today. So if we take a look, we will find the slope or rate of change at a given point. Today, we're just going to figure out if at a given point, if it's positive, negative, or zero. To determine the exact value, that requires calculus and what we call derivatives. We will learn that in Calc 1, so no use in spoiling the fun just yet. Now, if you wanted to find the rate of change or slope over a specific interval, we will learn how to determine if it's positive, negative, or zero, and how to find the exact value. So both of those we will knock out today. So we will get those three done today and save this one for calculus. Now, one other thing I really want to mention is when we find the rate of change over a specific interval, let's say from point A to point B of like this function here, and you want to find the rate of change or slope of that line, we call this finding the average rate of change. So not much changes besides we just add in that word average. It really doesn't change anything with the definition. So when you see the word average, don't get thrown off, don't get confused. It's just talking about over a specific interval versus at a given point. All right, so let's find the rate of change at a single point. So the way I like to describe this is think about where the point is as if you were on a roller coaster and you were at that point, right? So let's say you're at the roller coaster. If you're going up the roller coaster, let's say you're going up this way, at that point, you would have a positive rate of change. If you were going down the roller coaster, you would have a negative rate of change. And if you are at the very tippy top, so let's say you're right here, your rate of change would be 0. Or if you're at like the valley, so let's say right here, your rate of change would also be 0 because you're not going up or down. You're kind of just standing still either at the top or at the very bottom of whatever graph or roller coaster you're on. So real quick, what would the rate of change be for these scared people? So at this point right here, and so this should be 0, right? They are flat, and so 0 would be our answer there. This is a really good example, just kind of visualizing everything that I just said. So right, this would have a positive rate of change. At this point right here, T2, it's at the very peak. So this would be 0, and then here, this person's going down, so this would be a negative rate of change. Right, let's get to example 1. The figure shows a graph of the function f with 3 labeled points. Order the rate of change of the 3 points from least to greatest. All right, so what we want to do here is take a look. At A, we don't know what the exact value is, but our rate of change here is going to be positive. We know that for sure, and so we can say A is just a positive rate of change. B is going to be negative because it's going down, so B is going to be a negative number. And C, it's right at the bottom, right? So it's kind of not going up or down, so C is going to be 0. So while we don't know exact numbers, that's fine. We can still order these from least to greatest. A negative number is going to be less than C, which is going to be less than A. Or you could write this as that. Either way would be fine. All right, example 2. Now we have 4 labeled points, adding one more point into the mix. Where's the rate of change the least? And so what we want to do here is take a look. At A, we know this is slightly positive. B is also positive. C is slightly negative. And D is also negative, but a little bit more steeper. So now what we kind of want to do is just in comparison, to compare these to each other, let's guesstimate some of the slopes, right? Kind of like what we did in lesson 1.1 when we, guesstimated the slopes for here and we said our rates of change are going from 1/2 to 1 to 2. Let's kind of do that here. So maybe at A, it's going to be a positive number, so maybe positive 1/2. B, we could estimate maybe that's around 1. All we know, though, for sure is that B is going to have a bigger rate of change than A. Now, in terms of C and D, C could be negative 1/2, right? It's not super steep. And D might be, it's pretty steep, right? Let's go negative 2. The only thing that's important here is that D is going to be less than C. And obviously, since C is a negative number, it's going to be less than A, which is less than B. So D should be our answer. You will see one of these questions appear in your test in some form, so just be on the lookout for that as well. All right, example 3. The graph of the function y equals f of x in the xy plane always, when you see words like always or never in a multiple choice question, those are going to be keywords that you really should look out for, has a negative rate of change. Which of the following definitions for x and y would best model this function? So this means always having a negative rate of change, meaning it's going to be what we call in math constantly and then decreasing, meaning it is always going down. So let's kind of model each graph here. So A, B, C, and D. So A, the age in years of a young child, and then the height. So what I would probably say is, right, as you get older, you probably get taller. So maybe a function that looks like this is what I would say A is. So this is increasing, right? It's probably going to be an increasing function. So we can eliminate A. B, x is the total number of points scored in a basketball game, and y is time remaining. So you start with the maximum amount of time remaining, and then you go down, and the points keep going up as you go through a basketball game. So that's going to be kind of that type of line, right? It's going to be constantly decreasing, though. At no point will you be going up in points when you increase the time remaining, because you can't add time back onto the clock unless you're like a time traveler, and we can assume that that's not the case here. So B is probably going to be our answer. Let's look at C and D just to make sure. So C, the time in seconds since a ball was thrown in the air. So time, and then Y is going to be the height. And so this is probably going to look something like this, like a parabola, where it's increasing, and then when it gets to the peak, it's probably going to decrease. So it's not always decreasing or always having a negative rate of change, so that's why C would not work. And then D, the radius in meters of a circle and the area in square inches of the circle. This is probably going to be an exponential function, where this is radius and then this is area, because pi equals, or area equals pi r squared. So it's probably going to be some exponential function like that. Nonetheless, it's going to be constantly increasing, so it should not be d. All right, now let's find average rate of change over an interval. So here, very similar to rate of change at a given point, we're just looking to start with, for this lesson, seeing if it's positive, negative, or zero. Basically, if we're looking at point A and point B, so let's say we have the graph here at A and B, and we have this graph here, and we're looking at A, and we're looking at B. It doesn't matter what happens in between, because the only thing you want to do is connect the lines, or connect the two endpoints of the interval, like so, and then find the slope of those with those 2 points, right? So we all know how to find the slope, but right now we just want to see if it's positive, negative, or zero. All right, so it doesn't have to be matching up with the line. In actuality, if we were to have that, we could have this function look like this, and it doesn't matter because it crosses through those 2 points still, right? All right, now let's take a look at example 4. We have the function k is defined by this parabola from -10 to +10. Which of the following statements is correct? So here, if you would plug this into Desmos, you would typically be given Desmos for a question like this. And so we can see some key points here. Obviously, this is a parabola, so this is going to keep going downwards in both directions. You should have like -10 down here and then +10 here. So just imagine those lines continuously going down. All right, so first, k has a negative rate of change from -10 to -0.663, which is this point right here. And so that's going to it's going to be from way down there all the way up here. This should be a positive rate of change, so we can eliminate A. Let's take a look at B. K has a positive rate of change over the interval from -0.663 to 5.605. This is going to be from here to here, right? Those are those two x coordinates, which if we connect the points, even though it goes up and down, this just stays stagnant, right? That's what the rate of change is. And so it's not going to be B. This actually would have a rate of change of 0. Let's take a look at C now. From -10 all the way up to 2.470, this is going to have a negative rate of change. And so here, -10 should be way down there. This point is at x equals 2.470. So that's just going to be like that. That's going to be a positive rate of change, right? Because it's clearly shooting up. And so D is going to be our only answer left. Let's take a look and just make sure it's correct. So here, from 2.470 all the way down to -10, this is going to be a negative rate of change because it's going downwards. So D is our correct answer here. Taking a look at now the specific value of the average rate of change over an interval. So basically all you want to do is find the slope of the line between two endpoints. It does not matter what happens between them, right? So if we have this and we're looking at the average rate of change from, let's say, 2 to 5, it doesn't matter what happens. We are just finding the slope between those 2 points. Remember our slope formula, so rise over run, but more importantly, with 2 coordinates, you're going to want to plug them in here. Remember, it doesn't matter what's x1 and x2 or y1 or y2. It's going to basically be the same. You should get the same slope regardless. So just make sure to not mix up, subtracting negative numbers. Those turn into addition. So just be careful of those small mistakes. All right, so let's go through an example. If we wanted to find the average rate of change of this graph from 0 to 8. So let's ignore those 4 points. That was just so I could get the graph. It would just be finding the slope of the red line on the graph to the right. Now notice how we could care less what happens in between. We're just looking at the endpoints. So we want to find our first coordinate. Whoops, that's a really messy arrow. We want to find our first coordinate when x is 0. So when x is 0, this would be this coordinate right here, 0, 4. And then we want to find another coordinate, our second pair, when x is 8. And this should be 8, 0. Once we have these 2 points, we're going to plug them into our slope formula. So remember y2 minus y1 over x2 minus x1, which is 0 minus 4 over 8 minus 0, negative 4 over 8, which should be negative 1/2. And that's what we got here. And so that is going to be our average rate of change, right? So m, or average rate of change from 0 to 8, is equal to negative 1/2. Right, so example 5. The figure shows a graph of the function h of x. Of the following, on which interval is the average rate of change the greatest? So let's take a look here. So if we're looking from 2 to 3, that's going to be this rate of change. So the slope of this line should just be 0. From 3 to 5, that's going to be around this point in here. Slope of that line should just be minus 1. From 5 to 7, that's going to be right there. The slope of that line should just be plus 1. And then from 7 to 8, it's hard to see, but 8 looks like it's going to intersect right there. But obviously, if you think it intersects right there, you would get like a negative number. Let's just say it intersects right there. That would be 0. So where is it the greatest? C is going to be your answer. I will say on a quiz or a test, I won't have anything that's open to this much interpretation on like where does it cross the line at x equals 8, right? That's a little tricky. So nothing that specific in terms of finding exact values, but nonetheless, C should be our correct answer. All right, example 6. We have the figure showing the same graph. What is the average rate of change over the interval from 2 to 4? So what we want to do is we want to find our 2 points when our x coordinates are 2 and 4. So 2 would be 6, and 4 would clearly be 6 as well. So if we kind of connect those dots, we can clearly see right now that the average rate of change is 0. But if we plug this into the slope formula, it would be confirmed that it would be 0 because 0 over 2 is 0. So 0 should be our answer here. All right, 7. You may be asked to find the average rate of change using a table. And so here, we want to find the average rate of change from the interval from 0 to 3. So remember, take our 2 points when x is 0 and x is 3. At 0, our y-coordinate is going to be negative 2. So that's our first point. And then at 3, it should be 4. Plug this into the slope formula. So 4 minus negative 2 all over 3 minus 0. Now this is where I said make sure you don't get confused with the negatives and the subtraction. This should be 6 over 3, which is 2. And so C is going to be our correct answer for number 7. And number 8, I could give you a function and ask you the rate of change over a function. So here we're looking at it from negative 1 and 2 as our 2 x coordinates. And we want to find our y coordinates, but we're not given them in a table or a graph that we can easily look up. This is actually going to require a little bit of, I know, shocking math. So to get these, remember, all you got to do is just plug negative 1 into the function and plug 2 into the function as well. So if we want to find g of negative 1, this is going to be 2 times negative 1 cubed minus 4, which is 2 times negative 1 minus 4, which is minus 2 minus 4, which is negative 6. So this should be negative 6. Now if we want to do the same and find g of 2, this is 2 times 2 cubed minus 4, which is 2 times 8 minus 4, 16 minus 4, and we should get 12. Now we can plug this into the slope formula. So 12 minus negative 6 over 2 minus negative 1. This should give us positive 18 over 3. And so our average rate of change, or slope from the line of negative 1 to positive 2, should just be 6. So 6 would be our answer here. All right, so if you have any questions on anything I covered in this lesson, please come into office hours, shoot me an email with the questions. I would be happy to answer them, and I will see you guys later. Thanks.